Hello friends, today we will study about digital registers जिनको हम बाइनरी रजिस्टर्स के भी बोल सकते हैं। जैसा कि आपको पता है कि एक जो फ्लिप फ्लॉप है उसको हम 1 बिट स्टोर करने के लिए यूज कर सकते हैं। A flip flop can be used as a 1 bit storing device. Okay, now if we want to increase the capacity to store more number of bits, then we have to add number of parallel flip-flops with a common clock signal. This grouping is known as register. And the size of register is equal to the number of flip-flops present in a register. For example, an n-bit register contains n number of flip-flops. Now there are different types of registers available depending on how the data is given as an input and how the output data is retrieved from a given register. Depending on this, there are 4 different types of registers. First is serial input, serial output register, that is shortly known as SISO. Second is serial input, serial parallel output register, SIPO. Third is parallel input serial output register, that is PISO. And the fourth is parallel input parallel output register, that is PIPO. Shortly we can call them CISO, SIPO, PISO, PIPO. Okay. Now we will start with serial input, serial output register. Take an example of a 4-bit register. Or a shift register. Please remember that all these flip-flops are also known as shift registers. Take an example of a 4-bit CISO, that is serial input, serial output register. Then it can be designed like this. This is FF3, this is FF2, this is FF1, this is FF0, and signal lines are drawn with red. This is D underscore N, this is Q0, sorry, Q3, Q2, Q1, Q0. Q3 is given as a input for next flip-flop, that is FF2. Q2 is given as a input for next flip-flop, that is FF1, and like this. So if we are using a common clock signal with positive edge triggered, or it may be a negative edge triggered with all the flip-flops, then it forms a 4-bit serial input, serial output shift register. How it works? Suppose if clock is there, please remember clock can be a positive edge triggered or a negative edge triggered. Here in this example we have considered positive edge triggered clock. This is D underscore N signal, this is Q3, Q2, Q1 and Q0. Suppose we are given positive edge triggered clock, now this is first clock edge, this is second clock edge, third clock edge, fourth clock edge, fifth, sixth, and so on like this. And if we are given 1 0 0 1 1 1 data in flip-flop, then how this will flow? Suppose the flip-flop is initially cleared and this clearing operation is done with the help of a clear pin. and this is your clear pin, and all the flip-flops are initially cleared. Then after first clock edge, what will happen? This 1 is inserted at the output of FF3 and it becomes 1 0. This 0 is shifted here, this 0 is shifted here, this 0 is shifted here, like this. After that, this 1 is shifted at this Q3, this 0, sorry, this 1 is shifted at this Q2, this Q2 data is shifted to Q1, and this is shifted at this position. After that, this is 0, this is 0, this is 1, this will be 0. Now that this is 1, this is 0, this is 0, and this is 1, and this is 1, this will be 1, this will be 1, and this will be 0. Now we need 4 clock pulses to shift this data in from input side to the output side. That in first clock it will move from this position to this position, in second clock it will move from this position to this position, in third clock it will move from this position to this position, in fourth clock and it will move from this position to this position. And these are the 4 clocks. Okay, so it requires at least n number of clocks to receive output at the output pin. In this example, we are considered here 4-bit flip-flop, so it requires only 4 clock pulse. Okay, and data is moving serially from input to output. Here is another way of looking this movement, that data is moving from left to right. Then this register can also be known as shift right register. We can also design shift left register, that data will move from right to left in this way. Like this. Suppose if we are using a 4-bit लेफ्ट शिफ्ट रजिस्टर अगर आपको डिज़ाइन करना है तो आप दिस इज Q3, दिस इज Q2, दिस इज Q1, दिस इज Q0, and this is your clear pin, and here we are using a positive edge triggered flip-flop. Then how we have to connect them. Here D0, here this is D1, D2, D3. Okay, So this is FF3, FF2, FF1, FF0. Then first data is to be entered from this pin. हमें इस पिन से डाटा एंटर करवाना है, तो this pin will behave as a data in pin. Now this will be connected, output of this will be connected to D2, then output of this will be connected to D1, then output of this will be connected to D3, and this will be considered as a final D out. Now this forms a shift left register of size 4-bit. Data will be entered from D node and it will be retrieved or received at the terminal Q3. Okay, that's all for this lecture. We will continue with the next lecture with the topic serial input parallel output shift register.